Hi class, we're going to talk about exceptions today. This is in chapter 15 of your textbook mostly. So exceptional handling is trying to handle the condition that, that are somewhat unexpected. And we like to explicitly recognize those conditions, which we call the exception, and have a program or part of the program to specifically handle each of the condition. So this is a little bit different style of programming. Instead of looking at, I write the program, I think about the whole flow, I'm actually thinking my program recognize specific condition that I like to what I call catch. And then I will respond to that. And so this is a different because it actually changed the control flow of your program, as we'll see some example. So let's first see the syntax about in C++ how is exception is being specified and how does the catching and handling of this exception being done. So we have to introduce three keywords in exceptional handling in C++, which is actually fairly similar to Java. So there are three keywords: try, throw, and catch. So try are a block of code which you are expecting either from this block of code or the code being included. For example, this piece of code between try might call another library function. And within this part of execution, that there's any condition that you would like to reflect. That is the scope of your exceptional handling. So try really define the scope of the code that you like to apply, the concept of exceptional handling. So then you have catch. So this catch is right after, immediately after the try block. So there shouldn't be anything between the try block and the first catch block. So by the way, since I mentioned the first catch block means that one try block, you might have multiple catch block. Each of the catch block is trying to help us to catch different kind of condition. If you just happen to be just one type of exception you need to handle, you might only have one catch block. But the thing is that at times you might have a different situation. We'll show you some example that how you might have a different catch block to do. Okay, and then in order for so now we have a try block and we have a catch block. And in order for this try blocks to notify the catch block that certain condition happen, that you're going to use another clause called throw. So throw is the third keyword, which is really the point when your control flow is moving from your try block in the middle of the try block usually and to one of the catch block right after this try block. Okay, we'll see that sometimes the throw clause happening in your code, in your own code, that you can write throw something. But also that this could be happening in other people's code. For example, if you're using JSON RPC CPP code, you actually, when you develop homework assignment number 3, you actually saw some exception. And the thing is that you didn't actually use throw in your code to generate those exceptions, but those code were produced in the library. In the JSON RPC CPP code, they actually generate the throw. And if you actually write the catch and put that call to the JSON RPC within this try block, that you will be able to catch those exceptions as well. Okay, so this is kind of the high level idea about exception handling. Remember the three keyword: try, catch, and throw. All right. So what we're talking about conceptually about the concept about exceptional handling is showing on this figure. So on the left, you have a program. I'm using a example of flowchart to represent a program. So your program without exceptional handling, is supposed to follow the flowchart and then to execute the program, whatever they want to do, according to the designer of the algorithm. Well, however, with exceptional handling, there's a three issue we need to consider. The first issue is called detection. Your program in the logic detect that certain condition that happen in your program is unexpected. So in fact, in the program, that every point in the execution, we can check for a certain condition. And sometimes the condition is called invariance. So for example, in C or C++, you can use a clause called assert. So assert basically is assert as a keyword, and then you put parentheses to say, okay, what condition must be met at this point. And assert is dealing with some condition, which is whether it's invariant, should be invariant at this moment. And therefore, if this condition does not meet the invariance condition, the program will stop. So assert is a way for you to insert the code of assert when the program reaching certain unexpected condition. Don't try to fix it, die or crash, and then basically you have to fix a bug to actually to make sure that this assert won't happen. And usually in certain critical software, this is important. It's called fail stopped. When you fail, you stop. Okay, that's one side. Exceptional handling is trying to handle certain condition is they're both unexpected, but the program is still safe to continue to execute. I mean, for example, if we talk about segmentation fault, and segmentation fault is a very serious error, and it basically potentially the whole memory is corrupted, and this piece of software happened to control a robot, and therefore it's unsafe for you to continue to execute the program. So you should use fail stop, and you should just assert or do whatever. But segmentation fault should be just make sure your program won't continue to execute. Okay, that's one case. In exceptional handling, however, we're dealing with something which we think that the most critical property about our system or our program is still valid. It's just certain thing which we really don't know why this is happening. We'll show you some example. And I think the program need to continue to move forward because we want to provide some robust service, just like we have server that running for this class, and we like the server to be available and stable as much as we can. So sometimes some of the error we should let it go, and then we just continue. So the first thing is in the exceptional handling is about detection. It's detecting the condition, also detecting whether you think that this condition allow us to move forward, or we should just like assert or just kill the program by exit the process. Okay, so the number one is detection about certain conditions. So you're the programmer or whoever wrote this program. For the library we're using, they know where those conditions need to handle. So that's the first step. The second part is I call it control flow transfer. So what do I mean by control flow transfer? In this diagram, you see that there is a diamond shape in the middle, which is actually checking some condition. And that condition, if it's true, I will move forward. But if it's not true, I know there's something which concerns me. And instead of letting this program continue to go, I'm actually going to transfer my control to a different program on the lower right corner. So that is a catch. So you see that you have a program, the whole program is under try, and at some point that you're going to decide that condition met, and then you're going to throw. And when you throw, that the program essentially is transfer the control. It was controlled by the flowchart on the right, on the left, but now it's actually being transferred to the right. I mean, for example, this could be when you try to open a file and the file doesn't exist. And if the file doesn't exist, I mean, there is no point for you to keep moving forward. Or when you allocate a memory, the memory doesn't give you enough memory because your resources are low. And the thing is that those are the situations you need to handle differently. So you have to transfer your control to another piece of code, which is the catch clause, to handle that particular exception situation. Okay, so for catch to handle the situation, also it needs information. It needs to at least know what kind of problem that we're dealing with and what kind of unexpected condition we're dealing with. So there is a third part is you need to pass in certain argument into the catch clause and such that the catch clause will have enough to do the handling. Okay, so there's three things in the exceptional handling. Number one, detecting the unexpected. Number two, you need to use the throw and the catch to complete the control flow transfer. And the third one is that you need to passing the information from the try block to the catch block, and such that the catch block will have enough information to respond to the unexpected properly. So let's see some example. So this is an example. I basically modify our homework assignment number 4 when we talk about this work study, employee, and student. And what I did is, this is a very simple example. You can see I have a 1 try block and 2 catch block. So the difference between this 2 catch block, by the way, how do I actually match which catch I'm really trying to throw? We use what we call typed, the type of the argument. Really, I mean, by number one, the catch clause can only have one argument. That's the design. And therefore, the type of this argument will determine that which catch it will match to. So I have 2 throw statement within this. I can show it to you here. That one is the red, one is the green. So the first red one is basically check whether the object pointer that is a null or not. If the object pointer is null, that is there's not much things we can do. So we throw what we call a null pointer. So you can see that the second part, the second catch clause, which is in red, is basically taking a string. So that's why the null pointer double quote is a string. So it will match with the second catch clause. Or I have another condition because within the homework assignment number 5, we have a tag index, has a variable called tag index. And what happens if that index is negative? Because we know that the index need to be positive. It should be 1, 2, 3, 4, 5. And therefore that tag index, if somehow in our program is a negative, then it's something worries us and we don't know what happened. So we want to throw another exception, which is catch by an integer n. So I'm actually throw the tag index itself. I want to just say, hey, you got this number in the tag. So you see that I'm doing control flow by also passing the information about what's wrong with this catch. So the green clause will be able to handle. So the green goes to green, the red goes to red. So the situation looks like this. Okay, if you hit the red one, so it means that your object pointer is null, and then you're going to do the throw null pointer. So when you hit that line, when you throw the null pointer, that you already detected, okay, the condition object pointer is equal to null, that's the detection. And now you need to do control flow transfer. So control flow transfer is immediately follow the throw statement and immediately go to the catch statement. Okay, the catch statement of the red. So you do some handling. And after you finish the catch, you're not going back to the exit point from the try block. You're going to skip remaining of the try block and start executing the code after the try and catch block. Okay, so you have a 1 try block and 2 catch block at this moment. So essentially, after you finish executing the catch block, you start execute the next statement right after the last curly bracket of the last catch block. Okay, so that's the control flow transfer and the information passing for this example. And we can do the same thing for the green. I mean, just want to tell you that this is the control flow because it's important that you see that your program control flow now is not follow the flow chart that you originally designed. But now because the condition that you actually jump to somewhere else. This is also similar in the Unix environment. There is another pair of the construct library call you can use. One is called set jump, one is called long jump. So set jump and long jump together, they have similar functionality to exceptional handling, like a try-catch block. But try-catch block is semantically richer. Furthermore, because it's richer and also it uses some kind of virtual function, we will talk about that later, it tends to be more expensive as well. Okay, but if unless you have a real good reason not to use try-catch block, you shouldn't use set jump and long jump for this kind of purpose. Okay. All right. So you can see that for the green, yeah, it will go to the tag, go to the catch, and then after the green, it will jump out of the whole try-catch block and then execute the remaining code. Okay, so that's the flow of control when you want to use this kind of try, throw, catch construct. You should know how your program will move forward. And hopefully, these things will happen rarely, but when it happens, you know that. Okay. Okay, so you have some idea about how to the exceptional handling works in the C++, and we actually show you some example. You can see that you have multiple clause, is multiple catch clause, and they are being matched by the type of the throw or the argument. For example, the first one was an integer, the second clause was a string, character star. Well, having said that, if you can passing the information, you can pass an integer or passing a string, and of course you want to think about, oh, why not passing an object? I mean, well, I can actually encode it and have more information, and that's exactly what we're going to do. Is that you can actually throw an object, and which make that object that pass, because I only have one argument, so it's good to put everything I want in one object, and then you can throw that object to catch clause. Okay, and so we are going to talk about two things from now on. Number one, we're going to talk about how do you in general to passing an object from the throw or from the try block to a catch block. The second thing is I like to talk about some what I call the standard library, the standard exceptional class, which is called class exception. Class exception is the root, the base class for the whole standard C++ exception condition. And of course, you can derive from this. And we will show you some example that you have been using that when you generate HW3 client.h and keep looking into this. They actually use inheritance from class exception, from class std : exception, means that they derive from the standard. So you can define your own, but you can also derive from the standard exception class as supported by C++ standard library, and then you can do that as well. Okay, so let's first take a look at some of the exception that you can see that now this is one of the exception that what we do here is that we have to, I'm using the standard exception. In this case, I'm looking at memory allocation. So for example, in this code, you have to, by the way, you have to include exception. That's the standard library you have to include. And in this code, in the try blocks, I actually try to allocate a huge array. And I'm actually allocate an integer array of 1000. I mean, for most of the modern system, if you want to allocate memory with 1000, that should be okay. I mean, unless you're using an extremely small machine, that this usually the allocation shouldn't have problem. But if you add that number to have another 30 or 40, which is 1 million or 10 million, that some of the system will start to saying that, well, I don't have that much memory to allocate to you. And then it will throw a condition. And so I actually have a try block is try to catching any kind of bad memory allocation. And then I have a catch. So you see now catch, I'm using exception, a reference notation to the object exception. And what it does is that I catch this is a object type, and this type is exception. And under this inside, then I can actually start to calling the member function of this exception object. For example, in the exception, there is a virtual function, which means that every derived class from exception should have is called e.what. Means that there is some description about this exception itself need to be displayed. So this is a very simple, just informative to tell you what went wrong. Okay. But one thing you might have noticed is that you see, wait a minute, the whole code is in the try block. I didn't see anything to do with throw. There's no throw, but still that this exception is being generated. But the thing is that is you didn't write the code for to throw this exception, but see that keyword new. New is a memory allocation, is when you try to construct a new object, you try to allocate a memory, then you try to call the constructor. So when you allocate the memory itself, you're using somebody else's code. And that particular piece of code that has a throw statement. So you basically include this piece of code in your own program, which is new, and at the runtime, it tries to execute. But the thing is that the author of the library decide that this particular condition is unexpected. I need to generate an exception object. So it happened to be, that's why if you write the code, say catch exception E, you will be able to catch that exception that's actually being generated by the by the library itself. So sometimes even you don't have the throw, but you should know that, okay, sometimes I need to write a catch. You just want to handle all kind of unexpected situation handled by the library I'm using. Regardless, this is a standard library, regardless of memory management, or even JSON library, that you can do that. And in order to let your code be more informative about handling different kind of condition. Okay. So the exception class looks like this. I'm going to show you the simple exception class, and this code you can actually find it in your machine under your include directory. And under exception, there is a constructor, and there is a destructor too. And also there is a function, which is a virtual function called what. Okay. So I do want to say that there is a convention to make you think that's interesting that you have a destructor, which is a virtual. So I just want to be brief that this is a convention that in C++ we have two kind of class. One kind of class is not polymorphic, and the other class is polymorphic. So you heard the term polymorphic class. What do we mean by polymorphic class? So polymorphic class means that you have a virtual table pointer. Means that you use some perspective about virtual function, virtual class, and such that you have a virtual table. And because the way that the virtual table or virtual function is handled, it actually triggers the way exceptional handling is being done. So therefore, in exceptional handling, sometimes even though your program doesn't need any virtual, just in case you don't need any virtual, but it will be good for you to make a polymorphic. And how do you make a polymorphic? One of the convention that people has done is make the destructor virtual. If you make the destructor virtual, then the whole class become polymorphic, and all the derived class become polymorphic, and therefore it will be handled with the polymorphic class, which we'll see a major difference when you want to do this exceptional handling later. Okay, so this is the definition. If you go to the class exception, it's a very simple class, but this is the class that you can derive from that. And and I mentioned about STD exception. So under STD, there is multiple class of standard exception that the system the library will produce, and also you can actually use those standard to inherit from that, and then to build your own customized exception class. For example, you have one part with a lot of what we call runtime error. So runtime error including the bad allocation, the bad casting, bad type ID, and you have what we call logical error. Logical error including, for example, you have some kind of out of range situation that you have an index that's supposed from 0 to 20, but your index is negative, for example. Okay, and then you have some other kind of logical errors such as overflow or underflow and things like that. So this is the condition that all have individual class that's under the STD library, and it all inherited from the class exception. So class exception is the root of everything, and they all have what, which I show you that what is a function that you can display that information. Okay. All right, so let's actually take a look and try to define our own exception. So here I gave this example. This example is from your from one of the program from chapter 15 of our textbook. Okay, so I define a class called my trouble. And at this moment, I'm not using exception. I'm using my own class. So you can see class trouble is basically is a is just a class, and with a string message, I do implement my own what, which is just return that message. And then I have a constructor is you put in the problem. So you said there is a problem, and then whenever somebody want to throw this as an exception, the catcher is going to call this what to print it out. Okay. So this is a very simple. You can do the same thing to do you don't have to use the exception. You can write your own. Okay, so here is a driver program that you should try it because this is a part of the small program that you can run. That this main function is basically checking whether the trouble is should be called in different conditions. So here, the interesting part is that I have two different kind of trouble throw here. So you can see that if I is equal to 0, I'm going to throw trouble and has a curly bracket, which is called bracket initialization without any string. So if you go back, then if you do that, the default is going to be the string that when you create it in the constructor, and or you can actually insert another string, which is basically depending on whether I is equal to 0. If I is equal to 0 in the catch clause, that when you print t.what, you're going to see that default message. But if I is not equal to 0, then you're going to see the what saying that nobody knows the trouble I have seen. Okay, so this is just a tall example. It's a great thing the book went through a sequence of examples to let you gradually familiar with how this is done. Okay, I mean, in my opinion, that using exceptional handling is quite straightforward. But you have to decide what information you need to include it. And the information, okay, by the way, I said you can, you only can have one argument when you call the catch clause. But you could have multiple arguments when you call the throw. When for example, when I say throw trouble, in this example, I only have one argument. Constructor is one single string, but I can put 4, 5, or 6, or 400 argument there as a constructor of trouble and shovel in. So essentially, I can put everything. I can even put a JSON string into the trouble object, and such that the trouble object really contains a very rich format of information, and the whole object get passed into the catch clause. So that's how you communicate the information, even though you only allow one, but that one could be an object. When you have an object, you can have everything you want. Okay, so that's an example. As I mentioned to you, I want to show you that you have been using this code. You might or might not realize that. So this is a code from HW3 client.h, which is the code that generated by JSON RPC stub program that is generate this program. But if you look at toward the end of this code, this is our favorite function called getDistance. It's a function that you should be still remember at this moment, and you're using this JSON value and try to insert each of the value into the JSON value object. But at the end, you're actually going to check that when you call the method, by the way, this is from the client, so the client is going to communicate with a remote server, and the remote server is going to return the result, and that result need to be in the format of JSON value as well. Okay, so when you take that JSON value result, now if somebody define as a JSON value that there is a function called isObject, means that is this a valid JSON value object? So if it's the response, if is indeed is a good object, you return the result to your program. Your homework assignment number 3 is done. But what happens if that program is actually not giving you back, the server is not providing the right answer, then you're going to throw this exception called JSONRPC : JSONRPC exception, and then you put in a few parameter. You put two parameter, in fact. The first one, the throw, is because this is essentially a constructor. When you think about throw, it's really if you haven't constructed the object, then you can actually put your constructor input here. So it takes two parameter. One is basically just say the error code, error client invalid response from the client side, that is invalid. But the other thing is you get the result and using this nice function which you use a lot in homework assignment number 5, toStyle string. So you essentially put in a code and a string format of a JSON object into that exception and throw out and hope that somebody will catch that. Okay, by the way, when you call this function, you never write the catch routine. But now you can actually go back to your homework assignment number 3. When you call this function get distance, now you can actually put in a try block and then try to write the catch routine to catch if there is anything unexpected, how you can handle that. So it's kind of interesting for you to extend your homework assignment number 3 to do that. Okay, so then we talk about that class in the HW3 client.h. They use the class called JSONRPCException. Okay, that one, the code is, depending on your installation, is usually under the include directory, include JSONRPC/common/exception.h. So the definition of JSONRPCException can be found here. So let's take a look. First, this JSONRPCException, no surprise, it inherits from std_exception, like what we showed you before, that you can actually derive yourself out of the standard exception. And it has 4 constructors. It wants to take a different constructor using different type of information. For example, some of them using the string, and some of the most complicated one, they have both the code, which is y is the arrow, the string, and the JSON value object. You can take as many arguments you want in the constructor, all included in the JSONRPCException. And then, of course, it has a destructor, and not surprised, it's a virtual, because the exception has a virtual destructor as well, and that basically not do too much. Okay, there is one thing I think I skipped earlier, is that you will see that the exception at the end, they will say no except. If you see that the std_exception no except, means that those functions shouldn't generate another exception. That's another thing that's important. If you have something that's already handling the exception, at this time, you better not generate exception yourself. So the compiler is going to check whether this piece of code will generate any exception. So you will see that sometimes you will add, when you declare a function, you will see no except, which means that the compiler will check within the implementation of that function whether you have any potential generating throw. Okay. All right, and you have other code like get code and get message, get data, which because of those 3 variables as a member function, and you have your good friend. It's a virtual what. It's the routine that for you to do that. Okay, so if you look at this, it's really a very typical exception that you have a private variable, which including the code, the message, and maybe a JSON value object, and that is your program. And then you have the interface to allow people in the catch clause receive this JSONRPCException object, that they will be able to look into more detail about what's happening. Okay, and you can also take a look at the JSON RPC lib, and they actually tell you that what kind of exception they're handling. For example, they were saying this one is inherited from the standard exception. Okay. Okay, so now let's just recap a little bit. Okay, that we have the program that have the try and catch, has the throw, and the throw might or might not be there because you might call some function. The function inside of that function may be 3 or 4 layer down there. There's somebody catch or throw, but that exception will be propagate, will be catched by some middle library code, or nobody catches, so then your catch will catch that. Okay, so basically that exception will come up to be caught by the first catch clause it encounter that match the data type. So that's why it's important catch is looking at type and throw is looking at the type, and this two type must match. And the other thing which is also very important is that you can rethrow something. For example, this was generated by memory allocation, and somehow the code already have a exception, but it says that maybe the application program would like to catch this as well, so they can rethrow that exception. So which means that a exception might be able to handle by multiple catch clauses at different level, but with the same type that's need to deal with. Okay, and so in particularly we look at this exception, which is we talk about that you can use this general exception clause, and this will be the standard library and that we talk about. Right. So we're going to show you some example, but I just want to just go over this very quickly. That we have a standard exception, and you can just using this exception to catch a variety of error, and sometimes it need to be rethrow. So the exception class is being generated by somebody else. For example, bad alloc is usually throw when you call new. And backcast is usually when you do any kind of dynamic casting, or bad type ID is thrown by the type ID program itself. Okay, so there is a different kind of standard, but they all have the virtual function what for you to display the basic message, but each of them might have something else, like the way we design JSONRPCException, that we could actually do a lot of things that beyond what provides. So that's your power of developing more information being communicated. Okay, so here is the program. I actually took the homework assignment number 4, which is the part 1. We're looking at a huge array. By the way, this is so fun when I try to create a large amount of dimension in terms of the matrix and doing the copy ij, copy ji. So what I did is I want to show the result that's actually going to really, really large matrix and show the difference between copy ij and copy ji. So what I did is I tried to allocate as much as I want, but I want to do to a point which I just not break the memory allocation. So that's why I started using the try and catch block to do that. So if you look at my code, this is, I just keep generating this number called m size. And m size is a number which I keep increment at the outside loop of this try block. And every time I increment, I will actually do this m size. And you can see that whether the memory allocation is doing okay or not. And obviously over here, I don't need to do the throw block. Because why? Because the throw block is actually part of the new. So if it has some problem, the new is going to generate the bad alloc exception. But I do need to do is that I just write a catch clause, say catch exceptions. As long as you have this exception, and because bad alloc is a derived class from exception, that this exception will match the bad clause exception. Okay, so writing this code here, and then it will come in, and then the result looks like this. So you can see if when I run the program, when I give the M size, which is really big, before it break it, is the M size is 420,000. Means that I'm actually creating a matrix of a huge size of matrix, and basically it says the allocation is not good. Okay, so you can see that you can see the last part. You see that the last part, last three line in purple, that was the line, those three lines that's actually inside my catch clause. I actually printed inside the exception, standard exception, and also type IDE. Okay, so which means that it's interesting that there are three other lines before it actually reached my catch clause. Okay, so there's lines about this program, the can I allocate, the region. There is apparently some error message that's either it's just printed as error message, or this is generated by some of the inner part of the exception handling that's actually do that. And then potentially, now I cannot confirm, I have to look at the source code and then rethrow that exception possibly to my exception code here. Okay, so this is tell you that, oh, this is a really interesting situation that you can write this code to actually handle it, and then you decide what you're going to do. If it's the M size too big, then you can reduce my resolution to a little bit lower, such that I won't be able to deal with that. Okay. So one of the perspective, which is probably you see this first time, is I'm using the facility called type ID. So what is a type ID? The type ID is a facility for me to determine the class name, the class, and using that name means the class name of the object that was actually created. Okay, so you can see that now we can see that when I print type ID dot name, the name is not bad underscore alloc. By the way, if you look at the source code says the name of the class is bad alloc underscore alloc, but it's actually the name is st9 bad alloc. As st9 bad alloc. By the way, the class name using type IDs usually started with a number and then with the string that match your original definition in the class name. So therefore, there's two parts. One is the number, one is this. But because bad alloc is a standard library, so you add the st. But anyway, I want to give you a warning about using the type ID name, is that this is really environment dependent. A different compiler, a different environment, Windows, Linux, you might actually get something quite different. But you have to, how do you actually really interpret the result? That's actually very, very tricky. You have to, if you know what you're doing, you can use the type name to catch that. So one of the things I want to use here, this is a little bit like a virtual function or like a polymorphism. It means that the exception E is a base class. It should match any of the derived class as well. But then I want to find out what is my originally created class, which is the bad alloc. Then you can use type ID name. But by the way, you don't have to use this just for exception. You can use it for any kind of things involve virtual function or virtual table. So this is a runtime resolution. It's not a compiler time. It's a runtime resolution about how you can find out what's the name of the class, which is really similar to what you have with a virtual function situation or virtual inheritance. Okay, this leads to a very interesting issue I want to talk about, is that in order for you to be able to resolve this type at the runtime, which we call the runtime, the class itself or the object itself must be from a polymorphic class. What do I mean by polymorphic class? It means that it has a pointer to a virtual table, which means that if you create an object which is multiple inheritance in homework assignment number 4, it's not a polymorphic class because it doesn't have a virtual. But virtual inheritance, it is, because virtual inheritance has a virtual perspective, has a virtual table, has a pointer to that. So you can actually use the type ID. When I say you use type ID, means that if you don't have a polymorphic class, then you won't be able to dynamically resolve what is the original class that this object was created. It will just tell you that this is the class for maybe STD7 exception, because it doesn't have information. It just assumes it's an exception. But in order for you to use the real class, for example, to generate a bad alloc in this case, then you need to add this virtual destructor. That's why people adding a virtual destructor is just saying that push this class to become a virtual. And of course, you come with a good thing and bad thing about the virtual, but with that, then you can do this this type of type ID stuff. Okay. Okay. The other thing which is interesting, I like to share with you that this is not very obvious. I don't think a lot of people realize the difference. Is that if you want to define an exception, and you can also do multiple inheritance, means that you inherit one side from the exception and the other one from some other object. Like in this case, I'm actually simultaneously, I define my exception from both class. One is the standard exception. The other one is I create another my another. And then I basically construct my exception to be used in my program. So I actually have two different code here. These two pieces of code, they're exactly the same. The only difference is the order of my multiple inheritance. By the way, this is the same case worked for virtual inheritance as well. So whether the exception will come first in the exception inheritance list or it come the second. Okay. So if you pick the first example, which you actually inherit the exception second, but you inherit the my another first, you're going to see this error. You're going to run it in saying that this is uncaught exception of time, my exception abort trap. So your program will crash if you decide to do this. So in the exception, if you're doing inheritance, that it actually need to put this exception in the first place. Okay, so this is a trick just to let you know that this is true for both MI and the VI, is that if you want any type, not necessarily exception, that in order for you to match with the catch clause about the type, then that original type must appear in the LV, which is the first one of that multiple inheritance interface. Okay, so it has to come first, then the program will work. If you don't have it, you can actually write a program to test it. Just copy the program I showed you earlier to see that it's not a compiler error. Compiler will let you go, but at the runtime, it realized it cannot match with the code. Okay. All right. So we talk about today. We talk about exception. That I just wanted to remind you. There is three-part: the detection, control flow transfer, and how do you passing the argument. And then you can have your own exception object, or you can have your own trouble object, or you can actually use one of the standard library from STD, colon exception, or derive from that. I mean, this is an option that you can do. Okay. And the thing is that I do want to say that you have to think about one thing is for any language struct you have, you have to think about why we want to have this and why or in what situation we should have exceptional handling using the try, throw, and the catch. By the way, sometimes you know this, if you use it improperly, the program will look much worse. Okay, but this one, I just want to tell you there's a few things that you need to worry about. So exceptional handling is really nice tool for you to do software development. I mean, you can imagine when you do the software development, you're slowly make a progress. And the thing is that for a large complex system, you do not necessarily have a crystally clear concept about every single step in your flow chart. And therefore, sometime in the development, it's actually nice for you to start to using this catch clause to verify whether you think your program is getting the result you're getting. It's like using a debugger like a GDB, but you already include it in the program itself, and you communicate that what kind of condition, what kind of information that is expected or unexpected. So this is not only useful for your own software development, but also in case that you want to transfer this to a different kind of environment. Maybe it's a different machine, different operating system, or different version of the library. And the thing is that sometimes when you have a multiple or diversified type of environment, and your exception will be able to catch something which is unexpected, not because of your own code, but because some other code that will need to work with your code. Okay, so it's very useful for you to think about those kind of anticipation of the problem that you might occur in the whole software development cycle. And also, it makes your code very readable to others who want to see your code, because people can see by understanding the throw, catch, and try, they know that, okay, what kind of condition you think is expected, what kind of condition you think is somewhat unexpected. And then with the object, they can actually not only understand, they can help you to extend that to make it better code, or maybe it's easier for debugging as well. And the other thing which is also very important is that when we saw the bad alloc, you can think about something else is writing the code, and then we're going to catch that, and such that we will be able to know what's going wrong with that. So when you develop code that so far you have been using other people's library, but one of the day you're going to write a library for other people to use. And in that process, that to interact better with other people's code, that is very important for you to see that what kind of things you would like to communicate with that. Okay, so it's a good software tool, and used appropriately, it will really help in the software development over multiple platform or large team project. So this is some of the useful tool that you should really learn to use, and now you can go back to actually changing your own program and add a few exceptions and throw and help yourself to do that. Okay. In this process, I just want to also mention a little bit that when I first decided to take a look at the exception, I'm actually thinking about the server. You probably remember how many times that you cry out saying that, oh, the small program server is down. I'm sorry, that's my problem. Actually, I finally realized why it crashed so often. There was a bug in my program, but the thing is that it's an exceptional handling. How do we actually be able to build a server that's actually be able to do that? So I actually wrote a program that automatically check the status for the server. And I think right now, at least I can automatically share the service. You can click the link to do that. Okay? All right. Okay, that's our lecture today, and I will see you later.